All right, so graph of the logarithmic function. Now, y is equal to a to the x is the inverse of x is equal to the log of a to the base y. So obviously, from relations and function, you would know how to find inverse. So that is something that you could prove for yourself. That if you have f of x is equal to a to the x, that or yeah, that the inverse, let me see, y is equal to a to the x. Just running through something quickly. Let's take log to the base a of both sides. So let's interchange x and y. So we have x is equal to a to the y. Let us now make y the subject. So let's make y the subject. We have log to the base a of x is equal to y log to the base a of a. And so y is equal to log to the base a of x. And so f inverse of x would be equal to log to the base a of x. So in other words, log to the base a of x is the inverse of a to the x. Log to the base a of x is the inverse of a to the x. So the inverse of y is equal to a to the x is log to the base is log to the base a of y. Therefore, the graph of the logarithmic function can be obtained by reflecting the graph of the exponential function along the line y is equal to x. So that's something that you might not remember from CSEC, that the graph of an inverse of a function is the reflection of the graph in the line y is equal to x. So the line y is equal to x is a line that looks like this. So I'm just trying to give you an idea as to what this guy is saying. This is the line y is, this is the line y is equal to x. Now, if, and this would be the graph of, sorry, this would be the graph of this would be the graph of y is equal to a to the x. So if we reflect y is equal to a to the x in the line y is equal to x, we're going to get the graph of y is equal to log to the base a of x. And the reason for that is that y is equal to the log of a to the x is the inverse of y is equal to a to the x. All right. And so this is for the graph on the left is when a is what? Greater than, when a is greater than 1, a is positive and greater than 1. And the graph on the right is when a is a fraction, which is a is less than 1 but greater than 0. So if a is a fraction, the graph would look something like this. And so this is y is equal to a to the x, where a is a fraction. And if you, of course, if I reflect it in the line y is equal to x, so this is still the line y is equal to x, I'm going to get the graph of y is equal to the logarithm of a to the x. Though this is something to have a mental appreciation of, that the graph of the logarithm log of y is equal to log to the base a of x is the inverse of the graph of y is equal to a to the x. So, and we need to have an appreciation of what the graph of the logarithmic function will look like. Notice this is log to the base a of x. You notice that the graph for the log function is not that graph does not exist where a is negative, and that is because we do not find the graph of the logarithm of a negative number is not defined. So the graph does not exist where x is negative, neither on the graph on the left or on the graph of the right, because the graph of a negative number is not defined. You can see, however, that logarithm can be negative and it can be positive, but you cannot find the log of a negative number. So some properties. The domain are the positive values of x. So it's all x, where x is an element of the set of the positive real numbers. The range are the values, are all the real numbers. Y, the y-axis is a vertical asymptote. The graph is smooth and continuous. One is a decreasing function and one is an increasing function. This is important, something to mentally note. Recall that common logarithm is the term used for log to the base 10. So remember I told you last time that log to the base 10, calculators used to only calculate log to the base 10 and log to the base e. So in the old textbooks, you would see, I think, a lot about log to the base 10 and log to the base e. So recall that common logarithm is the term used for logarithm of base 10, and it is written as log to the base 10 of x, or LG10. So if you just see LGX, it's talking about log to the base 10. Logarithm having a base of e can be written as ln x. So log to the base e of x can be written as ln x or log to the base e of x, and they are called Neperian or natural logarithms. So log to the base 10 is called common logarithm, and log to the base e is called natural logarithm or Neperian logarithm. Neperian logarithm and the exponential function with base e are inverse of each other. So just like a to the x and log to the base a of x are inverse functions, e to the x and log to the base e of x are also inverse function. All right, and finally, so this is the graph of what the logarithm of log to the base e of x would look like. And it is the same as the graph of y is equal to log to the base a of x, where a is greater than 1, because e is also greater than 1. E is approximately equal to 2.718. And of course, the graph of that would be y is equal to e to the x, y is equal to x, and y is equal to e to the x would be the inverse. All right, so this would be the graph of y is equal to e to the x. And if you reflect that graph in the line y is equal to x, this is the line y is equal to x, you would get the graph of y is equal to log to the base e of x. And the reason for that is y is equal to e to the x, and y is equal to the logarithm of base e, the log to the base e of x. They are inverse functions.